Sometimes you want to compare two population means and look and see if there's any differences between them. We can accomplish it by doing either a confidence interval or a test of significance. And so we're going to start with a confidence interval. This is very similar to some of the other things that we've done in the past. But this time, there are two different samples and two different kinds of things we can do, confidence intervals and test of significance. So just like in the past, in a confidence interval, we're going to state what we're going to be talking about. We're going to define both of the means, mu1 and mu2, and state the interval we want to find. So you'll say something like, we want to find a blank percent confidence interval for the true population mean of blank, or maybe difference of means. In step number 2, when we do our planning, we're still going to be using our t confidence interval for the difference of the two means, because oftentimes when we take our samples, we're not going to know the population standard deviation. So we're going to have to use the t-test. And then we're going to talk about the random sample again. In talking about normalness, when you're talking about means, you're going to use the central limit theorem. So you're looking for a sample size of 30 or greater. That's the one big thing. If you're going to think about something today with means, don't forget we're looking for sample sizes greater than 30. And then independence, we still want the population to be 10 times our sample size in order to know that. And if it's not, then we're going to try and draw something that shows normalness. In step 3, we have a new formula. The new formula has to do with the means of both of the samples and the standard deviations from both the samples. Either they're going to give you tables that you can find it using the one variable statistics, which I'll demo in our problems today, or they're just going to hand it to you in a table, like the computer-generated table. It'll be one of the two. The thing that's really important today compared to in the past is when you're talking about degrees of freedom, you have two different samples, so you have two different kinds of degrees of freedom. You are going to use the more restrictive degrees of freedom, or in other words, the smaller degrees of freedom. So if I were going to write down a note right here, the most important thing is use small sample DF. Okay, so if one sample was 30 and one sample was 40, you're going to do the degrees of freedom 30 minus 1 for the smaller one if you have to choose between the two. Okay, so the smaller one, that's important. And then the last one, when you conclude, you want to say that we're blank percent confident that the interval from blank to blank contains that true parameter, and put it in the context of the problem. Let's try one. So in example number 1, we have a bunch of plastic bags from Target and Walmart. And we fill, we investigate by filling a random sample of 8 bags from each store to see which one can hold more weight. And then, here are the results. Target's results, Walmart's results, these are the different means. So as I start to do my process, the first step, of course, is always talking about what you want to do. So in this one, we will find a 95% confidence interval for the true mean difference between Target and Walmart. In carrying capacity, I guess. Carrying capacity. And we have to define some things, so let's call the target stuff mu t. So this is the mean capacity of target bags. And then mu w would be the mean capacity of Walmart bags. So we have those two means in here. There are 8 things. Obviously, we don't have a sample size of 30. We're going to have to draw a picture later on. In the next part, we talk about the planning part. So we will use and here's the big difference for today, a 2-sample T confidence interval for mu T minus mu W. So we've already defined what mu T and mu W are, so now I can start using symbols and I don't have to write the words anymore. So that's kind of the nice thing about when you define them. What else do we know? We have 2 random samples of 8 bags from Target and Walmart. So that's the test. That's the random. I'm going to do independent next. So we have 2 separate independent samples of bags where there are at least 10 times the number of bags as in sample, i.e. 80 plus. Since we took a sample of 8 bags, I'm pretty sure they hand out more than 80 bags. So that's good. Since our sample the samples are 8, we will look at dot plots for normality. So if we do a dot plot maybe for Target, and we know that the smallest one for Target is maybe somewhere around 23, 24, 25, 26, 27. Does it go past that? I don't even need that many, do I? Sorry. Let me erase that crap and start over, because that's ridiculous. So here's Target, 23. What's the biggest number for Target here? 25.2, 23, 24, 25, and then maybe I'll go a little bit past. We put some dots on there, so we got 23.1, so here's a dot right here. 23.7 and 9. So maybe here's 7, here's 9. We got 24.2, 4, 5, and 8. So 2, 4, 5, and 8. And then we have 25.2. And I don't know about you, but this is Target. And if I did Walmart, same kind of deal. Here's 23.
Did you ever do it on the same?
You can do it on the same one if you want to use different colors, so I can tell the difference.
Or can I do like X's?
Sure, sure.
Walmart starts at Walmart's only 19.
Oh, okay, 19?
Yeah.
19 to what?
Like 21. Oh, then there's no point.
To 21?
Yeah.
Okay. So 19 to 21. You could actually put them on this. If it makes sense, you guys can put. I'll do it on another one. If it makes sense, then I can do that. So the Walmart one, I mean, there's 19.8 and 6. So 19.6, 19.8, 20 point. Oh wait, there's 19.5 too, isn't there? Sorry, 19.5. 20.1 twice. And then a 3, 5, 7. Does that look right? So 3, 5, and 7 maybe. As I look at both of these plots, They look approximately normal. It doesn't look like there's any outliers. So from dot plots, we see samples approximately normal. So now we do the math. And in the math, you have to remember that we're going to be doing that 2-sample t confidence interval. The formula for that is x bar for Target minus x bar for Walmart. I would put that in parentheses myself. Plus or minus your t star value, which is the t-score, and then the square root of, and it looks almost exactly like the one sample, you guys. So this is the standard deviation for Target squared over n from Target plus the standard deviation from Walmart squared over the sample size from Walmart. So this you'll recognize, like without the Walmart stuff in there, it looks just like our one sample. So the difference means you're subtracting the means, and then you add in the other standard deviation stuff. So no biggie. You do your one variable statistics. When you do your one variable statistics, you find out the following. So x bar for t, you need s for t, and you need the degrees of freedom for t. And so this one for x bar for t is 24.23. To 2 decimal places, I should go farther, but I'm running out of room. The standard deviation is 0.658. And the degrees of freedom is 7. And actually that's true for both of them, so I could put Target and Walmart, I guess. So x bar for W is 20.075. S for W is 0.423. And so when I calculate this, after you've written down the formula, it would be good to plug in the numbers to show the reader. So when I do this, if I were you, I would write down the formula. I'd write down the numbers in the formula. I'd write down your one variable statistics that you got, and then you can show the interval if you want to after that. And I'm sorry, but I'm almost out of room here. So I'll write down the stuff in here. I would write down 24.23 minus 20.075 in parentheses, plus or minus for the 95% confidence interval, I think it's 2.365. So somebody can check me on that for degrees of freedom of 7. And then it's plus or minus the square root of. And then down below on each one, of course, these are 8s.
Doesn't need to be one.
Okay, so it wasn't plus or minus in front of the square root. Sorry, it's multiplied by. And then on the top, this is 0.058 squared.
Attention, Hopkins High School.
Here we go.
Dad, it's 0.658. You guys still have
Did I put 5?
No, you put like 0. Like it looks like you didn't like fully complete this.
Okay, so this is 0.058.
658.
I mean 658. I said 0. Okay, thank you. Sorry.
Yeah.
And then the second one is 0.423 squared. What you find out is that this interval is 3.495 to 4.804. And I ran out of room, but here's what you write down for the conclusion, since you guys probably have a little bit of room left. We are 95% confident that the interval from 3.495 to 4.804 contains the true mean difference in the capacity of grocery bags from Target to Walmart. What that means for us, really, is that Target bags are holding 3.5 to 4.8 more pounds than the Walmart ones. That's what it's saying. Yeah, so that's the in context part. So this interval tells us that on average, Target bags hold 3.4